Good day. So for today's video, we will be learning about approximation using Taylor polynomials. So a Taylor series approximation uses a Taylor series to represent a number as a polynomial that has a very similar value to the number in a neighborhood around a specified x value. So here is the general formula for the approximation using Taylor polynomials. F of x is equal to f of a plus the first derivative of a over 1 factorial times the quantity x minus a plus the second derivative of a over 2 factorial times the quantity x minus a squared plus the third derivative of a over 3 factorial times the quantity x minus a cubed, and so on. Alright, so for better understanding, let's have an example here. It's actually a quadratic Taylor polynomial. So using the quadratic Taylor polynomial for the function is equal to 1 over x squared, approximate the value of 1 over 4.41. Alright, so it's very important that we should first rewrite the formula from the given question. So since this is a quadratic Taylor polynomial, so we should have our formula up until the second derivative of a over 2 factorial times the quantity x minus a squared. So let me go ahead first and have my extra sheet here to write down our formula. So that's gonna be p subscript 2 of x is equal to f of a plus the first derivative of a over 1 factorial times the quantity, times the quantity x minus a plus the second derivative of a over 2 factorial times the quantity x minus a squared. There are actually suggested steps for approximating values. First, identify a function to resemble the operation on the number in question. Number 2, choose a to be a number that makes f of a easy to compute. And third, select x to make f of x the number being approximated. So for this, we should need to have 4.41 to be in the form of x squared, because it's very important that we know exactly the value of x and as well the value of a. It's gonna be x squared is equal to 4.41. X squared is equal to the quantity of 2.1 squared. So then we can say that x is equal to 2.1. Yes, 2.1, and then a is equal to 2. Alright, so let me have another paper here so that we could have the values for the f of a for our second derivative and as well for our second derivative values. So it's actually given that f of x is equal to 1 over x squared or x raised to negative 2, so that we can compute for the first derivative. That's gonna be negative 2x raised to negative 3. And for the second derivative, that's gonna be 6x raised to negative 4. Alright, but first let's eliminate the negative exponents so it would be convenient for us to solve our approximation later. Taylor series are extremely powerful tools for approximating functions that can be difficult to compute otherwise, as well as evaluating infinite sums and integrals by recognizing Taylor series. So here, we will need to just substitute all the values that we have just computed a while ago. That's gonna be p subscript 2, substitute the x value, that's gonna be 2.1, is equal to f of the value of a, that's gonna be 2, plus the first derivative of 2 over 1 factorial times the quantity 2.1 minus 2, plus f second derivative of 2 over 2 factorial, and there should be a plus sign here, sorry for that, times the quantity 2.1 again minus 2 squared. So there, we will just simply evaluate this, and since we know the f of 2, we just need to substitute the value of 2 here, 1 over 2 raised to 2, or 1 over 4, plus, since this one is negative, that's gonna be negative 2. It's gonna be negative 2 over 8, since we substitute the 2 cubed, over 1 factorial times the quantity 0.1, plus, for the second derivative, that's gonna be 6 over 2 raised to 4, that's gonna be 16, all over 2 factorial times 0.1 squared. So let's further evaluate this. That's gonna be 1/4 plus, so since this is over 1 factorial, it would be the same, that's gonna be negative 2 over 8, or negative 1/4 times 0.1, plus this would be 3 over 16 times 0.01. Okay, next, let's further simplify this one. It would actually be best if we will convert this one into decimal points. That's gonna be 0.25 minus 0.025 plus 0.001875. So to sum up, that's gonna be 0.226875. Okay, so that's gonna be our approximation for the given example of 1 over 4.41. So just to check if we arrived to the correct answer, let me get first my calculator here, and let's plug in the value of, okay, that's gonna be 1 over 4.41, and the answer would be 0.2267573,696, which is similar to the one that we have just approximated up until the third decimal point. Alright, so let me have another example here. So find the fourth degree Taylor polynomial for the function is equal to ln x, centered at a is equal to 1, and use it to approximate the natural logarithm of 1.1. So we have now here the formula that's gonna be up until the fourth degree. So simply we'll just need to have the value of x is equal to 1.1, and the a would be equal to 1, which is actually given from our question. So there. So let's now proceed and finding our value for the first derivative, second derivative, third derivative, and the fourth derivative. So given our function is equal to ln x, let me write it down here. Okay, so our first derivative, that's gonna be equal to 1 over x. Our second derivative would be negative 1 over x squared. And for the third derivative, that's gonna be, okay, I'm sorry, I forgot to put a negative sign here. So for the third derivative, that's gonna be 2 over x cubed. Our fourth derivative would be equal to negative 6 over x raised to 4. Let me have another paper here so that we can proceed to our next process, which is to substitute all the values that we have just calculated a while ago. Okay, that's gonna be p subscript 4, since we are in a fourth degree, of 1.1. That's gonna be the value of x, yes, is equal to f of a, which is the value of 1, plus the first derivative of 1 over 1 factorial times x minus a, or 1.1 minus 1, plus the second derivative of 1 over 2 factorial times 1.1 minus 1 raised to 2, plus the third derivative of 1 over 3 factorial times the quantity, oh, forgot to put the 2 here, times the quantity 1.1 minus 1 raised to 3, plus the fourth derivative of 1 over 4 factorial times the quantity 1.1 minus 1 raised to 4. Alright, so it would be easier for now to calculate this because we already have our computed value, which is f of x is equal to ln x, which our x for this would be 1. Okay, so the natural logarithm of 1 is of course 0. Plus, for the first derivative, that's gonna be 1, still 1, right? Times the quantity 0.1 minus, okay, for the second derivative would be 1 over 2 times the quantity 0.1 squared. Next, for our third derivative, that's gonna be, okay, plus 1/3, okay, times the quantity 0.1 raised to 3. And for the fourth derivative, that's gonna be, okay, negative 1 over 4 times the quantity 0.1 raised to 4. So let's simplify this one further. So that's gonna be, let's disregard the 0. That's gonna be 0.1 minus 1/2 times 0.01 plus 1/3 times 0.001 plus, negative 1/4 times 0.0001. Alright, so if we're going to calculate this, the answer would be 0.0953083333. Okay, so that would be our answer for the approximated value of the given question. So just to check, let me have my calculator here. Let's plug it in. The natural logarithm of 1.1, the answer would be 0.0953101798. So that is actually similar to the one that we have approximated up until the fourth decimal point. So that's all for today about approximation using Taylor polynomials. Thank you so much for watching.